Hello and welcome to SudoKanard. We are here to solve this Parity Parade Sudoku by Dutch author Richard Stolk. And Parity Parade is a variant that was invented by Glum Hippo at approximately the same time as Parity Party, and it's almost the same rule as Parity Party, maybe a little simpler. So whenever you have such a number in the margin, this number is the sum of the first few digits, and how many digits is determined by the first change of parity. For example, 13 could be the sum of a certain amount of odd digits, and then the first even digit that you would encounter. For example, it could be 6 and 7. Encountering this 7, we have the first change of parity. It could also be 2 plus 4 plus 7. 7 is the first change of parity. It could also be, let's say, 1, 3, 5. Oops, sorry about that. 1, 3, 5, and then 4. Then we have odd digits, and the first even digit just stops marks the first change, and the sum here is indeed 13. So this is the rule. As usual, I've put the link in the description to the place where Richard has published this puzzle. It's on the site called the World Class Puzzles from the Netherlands, and they are definitely world class puzzles, and they are definitely from the Netherlands. So I have already solved this puzzle, and I did it just to prepare this pen-pad interface. So let's begin. And the first thing I will say is that even totals are more constrained than odd totals. Because if you try to put first even digits and then an odd digit for the first change of parity, then you'll end up with an odd sum. So this can't happen, and such a total must begin with odd digits and end with an even digit. And furthermore, the amount of odd digits must be even itself, because if you try to sum, say, 3 odd digits, then an even digit, you end up with an odd total. So we know here that we have at least 2 even digits, and I will use green for even digits and orange for odd digits. And something else to know is that the sum of all 4 even digits is 20. So that this here can't happen for a sum of 18. And we have this configuration, and the same is true for 8. And the options are 1, sorry, I've completely done the inverse of what has to be done. So it could be 1 plus 5 and 2, it could be 1 plus 3 and 4, and there are lots of options here. Now, if you're familiar with, say, Kakuro or Kira Sudoku, you know that 27 will need at least 4 digits. So the change of parity will happen later than that. So those are even, those are odd. And here we have the last even digit and the last odd digit in the region. Here we know that we start with, we have at least 4 digits, and we start with digits of the same parity. So those are, and we start with digits that are odd, and an even number of them, for that matter. But I can't have 6 odd digits, so this is how it works. 4 odd digits and then an even digit. 27 will begin with at least 3 digits of the same parity. Yes, so exactly like this. So could it be, it couldn't be 3 odd digits because it would make 6 odd digits in the row, so that's 3 even digits, and then I have 3 even digits here and 5 odd digits there. And something we can see is that the sum of those 4 digits is 20. So at the first change of parity, we get a 7 here. And then here, those are from 2, 4, 6, and 8, obviously. But the maximum value we can have with 3 digits is achieved by 4, 6, 8, which is 18. And then the maximum value here comes with a 9. So 27 was anyway the maximum value we could have with such a configuration of parities. So it must be this way, and we now know that this 8 sum doesn't use the 4, so it must be 1 plus 5 here and the 2 there. Something next I'm seeing is that this 5 can only be the sum of 2 digits, because 3 digits sum to at least 6, and the same is true with 3. So 3 will be 1 plus 2, and 5 without using the 2 will be 1 plus 4. And this 5 here will be 2 plus 3 because it can't use the 4, so that the remaining digits here are 1, 5, and 9. And we must ask how 15 will be achieved. Just seeing that those are odd digits, we see that 15 will be the sum of those 4 digits, but 9 will be too big for that, so 9 is here. This is 13, so this is a 2. Those 2 digits here are 3 and 7, and they are as odd as can be. And let's see, we have 11. Those 3 digits must sum to 15. So from 1, 3, 5, and 7, only 3, 5, 7 work. The one that is here is not there. It must be somewhere in the column. So this is the sum of 2 digits without using the 3. This is 1 and 4. So what about the digits here? We know that 4 is somewhere here, 5 is somewhere here, and this is from 6 and 8. "25" will use at least 4 digits. Not sure this is deducible at this point. So where do we look? This 5 here is not 1 plus 4 because of that, so this is 2 plus 3. Well, where is a good place to look? Probably this 11. We see that we have 15 here. If we try to make 11 the sum of 3 digits, that's 26 for those 7 digits, and those 2 would have to sum to 19, which is impossible. So 11 will only use 2 digits. It's not 2 plus 9, it's not 7 plus 4, it's not 5 plus 6, it can only be 3 plus 8. So that this here is a 6. And 8 is in here, so that's the 4, and this is a 5-8 pair. And here we are left with 4, 6, and 7. And we must have a sum of 17. Those 3 digits sum to 17, so this is the change of parity. This is 7, and those are 5 and 6. And we get the 9 here just by the rules of Sudoku. Let's apply some coloring magic in here. This 14, just like 8 and 18, can only have 2 odd digits followed by an even digit, because, as I said, we must begin by an even amount of odd digits, and 4 odd digits would be too many. Then what? So let's ponder the fact that 3 can only be here in the column, so that those are 5, 6, and 8. 5, 6, and 8 sum to 19. So the change of parity must be in the third position. Some more coloring, because I like to do that. And let's just do some computation. That's 14 plus 8, that's 22. The sum of all 9 digits is 45, so the sum here must be 23. And the only way to have 3 digits sum to 23 is with 6, 8, and 9. And those now must be 2, 5, and 7. So 5 and 7 here, 2 there. That's a 3 here, that's a 2, that's a 1, that's a 5, that's an 8, that's a 3. And now, how do we achieve this 13? Well, this will have to be even, and this is the first change of parity, so this is 8 to have a sum of 13. Now, this is not 3 anymore. And this 2 here doesn't appear in there, it must be here. So this is 6, 8, and 9, I think. This is 5, this is 8. The other digit must be here, but it's not a 3, so this is 7, this is 3, this is 7. Well, this additional coloring is most probably not useful for solving the puzzle. Here the digits are 1, 2, 3, and 5. That's not 3. And actually, we already have 2 instances of 1 in those 2 rows, so those cannot be 1s. I'm seeing that in the column 2 can only be here. Those are from 4, 6, and 8. So what about this 25? Well, here we have 3, 5, and 9. And actually, that's the sum of 25. And I'm asking the question, was this clue useful in the end? I'm not sure it was. I may be wrong. I didn't pay attention. And here we have 4, 6, and 8. So more coloring. And this is not 8. This column needs 4, 6, and 9, but this could be disambiguated. So this is 4 and 9, I think. That's correct. This is 1 and 7. What about this? The maximum value with 3 digits is, with 3 odd digits is 9, 5, and 7. That's 21. So this is at least 6. And we can see that we can have 5, 7, 9 plus 6. But if this is 8, then this has to be 3, 7, 9. So in all cases, we have the 7 and the 9 here. And in all cases, we have the 7 here and the 9 in one of 3 places there. And I'm just wondering, is this 13 with 4 digits or with only 2 digits? Or could it be 3 digits? Well, there are several cases to investigate. I'm not sure I want to do that. This 19 looks more promising. Or at least I do hope it is. So what about this? 19 is the sum of those 3 digits. But there's a lot to look into, I'm afraid. I'm not sure this is the place to. Perhaps this 13 will bring more to the table. So what about this? So could we have 3 odd digits here? Obviously not, because we already have 3 odd digits. If we have 2 odd digits here, they will be 7 and 9, and that's impossible. So there is an even digit in here. So this 13, or it could be 2 even digits actually. With 7 here and 9 there. It could be 2 even digits with 3 or 5 there. But could it be could it be just 2 digits? I mean, we could have 7 and 6 here. We could have a 9 and 4. Well, a lot seems to be possible. So is this really the place to look? I'm feeling I'm missing something. Perhaps this 18 does more than I thought it would. For example, could it be 4 here? If I try to have 4, those two must sum to 14, so there must be 5 and 9, but there's a 5 here. So 4 is not possible. 6 would come with 12, which would be not 5, 7, so 3 and 9. And 8 there would come plus 10, so that couldn't be 3 plus 7. That couldn't use the 5 anyway, so it would have to be 1 plus 9. So this was 6 or 8. And I'm seeing that on this row, finally, 4 has to be here. This is 9, that's not 9. That's not 9. And I'm seeing that this is not 9. Well, the reason is that I need 2 cells with 6 and 8, and this was the only place for the second 6 or 8. So 9 goes there, and this is not 9, and 9 goes here. So this is 1, this is 5. And then those two must sum to 9, and 2 options seem to be valid. So here we have the other 1 or 2 or 3 plus the digit that is missing here, which is this digit there. But now this is starting to be interesting, because the 3 in the column can only be here. So we must have a 2 up there. And those are from 2, 4, 6, and 8. Yes, they are all even in here. And on this row, this has to be odd. And here we have an odd digit. And actually, this odd digit can only be 9 at this point. So that this is 5. And this is 4 or 6. So a lot can still happen here, I think. So there's no 9 in here. We still have to locate the 7. And I'm thinking 7 could work with a 3 here and a 2. No, it would not. No, actually, if this is a 2, then we need another even digit here than this odd digit. So, well, what could we have? Could it be 2 digits first? It could be 6 and 7, I think. 6 and 7. Did I miss some? Oh, yes, I missed an elimination down there. This is 21, so that's a 6. And that's the 4, that's the 6. And those digits here are 2 and 8. Those digits here are 6 and 7. So now we know that 13 won't be done with 2 digits, so it will need 3 digits, and this has, so we have to have the same parity here. So this is 6, this is 7, and those 2 rows are now to be disambiguated. So this is 7, this is 5, this is 11, so the sum is achieved with the 2 here. 2, 1, and 4. So that's it for this part, and I will do the useless coloring just because now I can. And it's time to disambiguate the bottom of the grid. How do we do that? So 1, 3, 4, 8. So 18 doesn't seem to be enough to disambiguate the lot. So what did I forget? Oh, what I've forgotten since the beginning is this 33. Here the sum is 25. The change of parity forces this to be an 8. So I probably lost a lot of time because of this. Now the rest is just disambiguated directly. Here I need 1, 3, and 8. So 8 goes here. And this is 3 to secure this 18 sum, so this is 1, and the rest should be straightforward. 5 here and 7 there. All right, so I probably made it more difficult than it needed to be, because this 33 could be resolved much earlier, and actually I should have kept track of the clues that were fully fulfilled. This would probably have saved me some grief during this. So, well, anyway, this was a very well constructed puzzle by Richard Stolk as usual. Thanks for watching this video and see you soon on SudoKanard.